and a very warm welcome to our next technical training for 3D testers. In this training I will show you about correct probing. Please let me begin with important notifications. Please clamp your 3D tester into a high-class colored chuck. Sorry for repeating, but the chuck is the basis of your measurement. It must be precise and stable. Before probing, runout must be adjusted. And now let me explain the difference between forward and backward probing. This is very important as backwards probing will not work fine and occur wrong measuring results. Probing in direction to the workpiece, that means forwards probing. That means you probe into the direction of the workpiece. And you see the large indicator, he moves from the green section to 0. This is forward probing. It's the same from the other side. Even from this side, you move in direction to the workpiece. The large indicator moves from the green section to 0. This is forward probing. Backward probing means you have already overdriven the 0. You see the indicator is in the red section, and then you probe in direction away from the workpiece to reach the 0. So that means the large indicator moves from the red section to 0. This means backward probing. And backwards, never. It's the same from the other side. You have already overdriven 0 and you probe away from the workpiece to reach 0. The large indicator moves from the red section to 0. This is backwards probing. Backwards, never, ever. Next point, probing direction changes. Direction changes do not work well. As our probing mechanism has gears and several mechanical parts which work together, direction changes will cause reverse errors. This is also known as backlash errors. Please watch this short sequence and see what I mean with direction changes. It's probing forwards, then it changes the direction, probing backwards, change the direction, and again probing forwards. This might be a wrong result caused by reverse errors. So direction changes, never. So probing forwards is the only way. Please see the short sequence about probing forwards. It's probing until 0, and this will be the correct probing and a correct result. Let us see how we can get the set reference of the 3D tester. The 3D tester is clamped into your tool holder. The tool holder is clamped into your spindle. But you have a tool length, what we call set reference. The set reference means the length from the probing ball to your spindle 0. That's the set reference. It can be measured in a presetting device, or you can measure with your 3D tester directly to your machine table. But please be reminded that 0 and 0, I mean when you reach the 0 and 0 on your 3D tester, needs a movement of 1.5 millimeters. So when you measure the 3D tester set reference in a presetting device, please be reminded that you have to take 1.5 millimeters into account. When we have the set reference, we can use the 3D tester to probe in set. Probing in set, just move your 3D tester onto your workpiece. Then move your 3D tester down in set minus and look to the indicator and its indication. So just move down as long as the indicator reaches 0. You get your position when the large indicator is at 0 and the small indicator is also at 0. In this position, enter your set value, what you read on your machine display, into your set offset, but take the set reference length into account. You can also probe in X and Y axis. This is very simple. Just position your 3D tester before your workpiece in X axis. Move forward in X axis and take a look onto the indication on your dial indicator. Move as long as you reach 0 and 0. Again, you reach 0 and 0, and in this position, this is the very special, in this position your spindle is exactly centered at the workpiece edge. That means here you see the red center line of the spindle, and here is your probing ball, and it's exactly on the workpiece edge positioned. So in this position you just enter the X value which you read on your machine display into the X offset. You don't need to take anything into account because you're exactly with your spindle on the edge. Exactly the same you can do in Y axis. You just move in front of the workpiece and you move forwards in Y axis. You look to your indication and you move until you reach 0 and 0. And again, you have exactly the position of your machine spindle. The middle of your machine spindle is exactly on your edge, and you read your Y value and enter the Y value into your Y offset. Finally, we can also use the 3D tester for parallel running. Parallel running works very simple. You just move your 3D tester to your workpiece. You look for an indication what you want. It's no matter if it's 0 or not. You just need an indication on your indicator. And when you have the indication, you can start moving along the edge of the workpiece to check parallelism. Left, right, and you can see the parallelism of your workpiece. And the good thing is, you can do this in all axes. You can do this in X and Y, and very special, you can also check parallelism in Z axis. Our probing system is very stable, so even the Z axis is measured correct. That's all. Probing is very simple with a 3D tester, so thank you very much for your kind attention. If you have any questions, please feel free to contact us at any time. We will be there for you. Thank you very much.